is on the move in a growing progressive American industry, which began with a single well drilled by Colonel Drake in Pennsylvania in 1859. Today, nearly 1.5 million wells have been drilled in the United States. Over 2,000 products come from petroleum, and oil comes from many parts of our nation to keep America on wheels. Yes, oil is on the move. Oil is under our lands, our seas, and oil is in the Rockies. Oil is in Nebraska, Colorado, Montana, and Wyoming. The Denver-Julesburg Basin had been opened. The new Adena field in Colorado was being developed. And there was increasing crude oil production in Kansas. Now, efficient methods of crude oil transportation were immediately necessary. Officials of the Pure Oil Company and Sinclair Pipeline Company felt that an important contribution could be made by the building of a large capacity 18 and 20-inch crude oil line to carry crude into major refining centers. This large diameter pipeline started at Marino, Colorado. Crude oil from the Denver-Julesburg Basin could be moved almost by gravity flow through Colorado and Kansas, through areas already producing or known to have possible production. This new line was to join Sinclair's Chicago Big Inch at Humboldt, Kansas. Thus, crude oil from all of the Rockies and the rapidly developing nearby areas could be made available to great refining centers. The Arapahoe was to be its name. The decision was made, and surveyors then started plotting the route, which up to then had been nothing more than a penciled line on a map. Right-of-way for the line had to be acquired. Over 1,200 landowners were involved, some nearby and some far away. Rivers had to be sounded, currents measured, and the methods of crossing determined. More than 79,000 tons of high-tensile, carefully tested steel pipe and casing had to be fabricated in steel mills and delivered along the route of the line. Many pipe yards at convenient points had to be established in Colorado and Kansas. Each one had to be handy to the spreads or crews working the area. There were actually 5 separate construction spreads or operating areas over the length of the Arapahoe. All kinds of terrain, from the Flint Hills of Kansas to rich prairie soil, had to be prepared for ditching. Access gates along the entire construction route had to be cut into the regular fencing to allow for the movement of men and machines. Modern ditching machines did the bulk of the trench digging. Most of the route of the Arapahoe was across soft, loamy soil that was placed neatly on the offside of the ditch so that it could easily be replaced after the pipe was laid in. With construction beginning late in August and operation of the Arapahoe hoped for by December, all phases of construction, including the delivery station at Humboldt, had to begin almost simultaneously. When the land became slightly rocky or a bit on the ledgy side, the backhoes took over from the ditching machines. When the backhoes bogged down, the heavy flint and sandstone had to be attacked by diesel cats attached to a rooter. Something had to give. Most of the country crossed by the Arapahoe is valuable farm or grazing land. Arapahoe officials specified that such land must be protected while the line was under construction. When mechanical means failed to budge earth or rock, the powder monkey was called into action. For farmed or grazed land, many light, gently nudging shots were employed. For land not so used, fewer and larger charges. where very rocky terrain was encountered, a big one generally did the job. Rarely did the path of the Arapahoe pass near established routes of travel. All pipe and casing had to be trucked from the nearest pipe yard over all kinds of roads to the company's right-of-way. Many of the workmen on this gigantic job of pipeline construction came from communities near the route of the Arapahoe. After stringing came the lining up of the pipe on skids. The direct path of the Arapahoe took it under or over all kinds of obstructions. Under was the order for a place in Kansas with the trunk lines of a railroad parallel to Federal Highway. This crossing, as it is called, involved boring under the highway and railroad so as not to hold up service for one single moment, not even slow it an iota. After the proper boring was completed, the casing which carried the auger remained in the opening made under the obstruction as protection for the line carrying the crude oil. It was a tough, ticklish job that involved many men and machines working smoothly with one another. Hills and valleys presented very few problems to the line contractors. In order that the pipe fit into its tailor-made trench, it had to be bent to conform with the slope of many a hill. Before welding could begin, beveled edges had to be buffed and cleaned. Pulling the line-up clamps into place was another exacting operation. First, a tack weld or stringer bead to hold the aligned position. Then a filler weld or first pass, actually a weld over a weld, almost half the thickness of the pipe. Each welder's working number was stamped on the welds he made. Then preparation for the wind-up of the welding operation. The final or cap weld actually stands a bit above the level of the pipe. High-intensity electric arc makes a band around the previous welds. So that no invisible flaws would remain to weaken a weld, thousands of welds along the Arapahoe were X-rayed shortly after they were finished. Where there was a defective weld, it had to be corrected before placing the line in the ditch. Once all welds had been X-rayed, inspected, and accepted, the line was made ready for an operation that would extend its life for at least half a century. The cleaning and brushing machine first removed all rust and foreign particles and was immediately followed with a prime coat of asphalt for additional protection from the ravages of moisture, cold, and heat. Then followed the flexible, nimble-fingered wrapping machine, applying another generous coat of asphalt, and in the same operation, completely covering the line with a specially prepared asbestos felt wrapping. Thus, many years were added to the life of the line through the prevention of corrosion. In every phase of construction, nothing was left to chance. To check the completeness of the wrapping machine's work, a device known as a holiday detector, or Jeep as the workmen call it, was drawn over every foot of wrapping. Where defects in coating were found, they were repaired by hand. Because settling rock in the ditches could possibly bring great pressure to bear on the ordinary wrapping where it crossed through rocky ditches, a second protective coating was used. Called a rock shield, it was applied by hand. Bound with steel straps, once again doped, this time by hand. At intervals dictated by the engineering staff, electrolysis test connections were installed with thermal welds. To complete the control of electrolysis, rectifying units were installed at proper locations. Dry washes and creeks, which were known to have a history of flooding, were treated as though they flowed year-round. Huge concrete river weights, weighing more than half a ton each, were placed at calculated intervals throughout the actual crossing area. This was done because flash floods have a way of deepening channels, and the additional weight provides negative buoyancy to keep the line from floating and washing out. While the pipeline crews were busy, tank construction crews were also building working tanks at the pumping stations. There were electric plate handling machines that moved one-ton plates about like playing cards. Hydraulic plate alignment devices that did the work of 5 men. Automatic welding machines that seemed to crawl around the surface of the rising tanks like huge spiders, one inside, another outside. Their operators connected by intercom systems. These and many other construction marvels all combined at Merino Station to produce 3 huge working tanks, each with a capacity of over 5 million gallons of crude oil. The middle of September saw some of the spreads or crews completing their sections, joining them and lowering in as they progressed. The early part of October saw temporary pipe bridges built for the blasting crews. With the dynamite charges in place clear across the stream, the crew cleaned up and brought wires ashore. The pipe bridge was towed to safety, the whereabouts of all personnel checked, and the order given to fire. Drag lines removed the mud and rock from the blasted underwater ditch. Then, with half-ton river weights already installed and a half-dozen cats urging it on, another section of the Arapahoe joined the category of finished. When other pipelines cut across the path of the Arapahoe, the line was installed at least 2 feet below the existing carrier. In the case of other obstacles, such as irrigation ditches, overhead crossings were made if the span did not exceed 60 feet in length. The chill of fall was felt when the final backfilling took place. Crews installing new fence had to face sharp winds. The chilly hand of Jack Frost was seen in the fields of eastern Kansas, where but a few short weeks ago, both men and machines had been. Snow had already fallen on the high plains of Colorado when the first crude started to flow eastward from the Merino station early in December. The Arapahoe today represents an up-to-the-minute example of engineering skill, design, and construction in modern pipeline practice. This project, conceived by the officials of the Sinclair Pipeline Company and the Pure Oil Company to keep America on wheels, was given the designation Defense Department Project by the United States government. It stands ready and available should needs of war arise. It makes available to the refining centers vast quantities of crude oil. How fitting then that it should be named after a brave group of Native Americans, the Arapahoe.